Hello my dear students, welcome to one more amazing session from Infinity Lane by Sri Chaitanya. This is Suresh, Faculty of Chemistry. How are you all doing? Hi Suresh, how are you? How are you all? So आज हम चर्चा करने वाले हैं VSEPR theory का hacks. I'm going to explain the total VSEPR theory along with valence bond theory and hybridization and predicting the geometry of the molecule. And this is a key point in the chemistry. You can get directly one question from this shape and geometry of the molecule. You can get one question from the NEET examination. I can guarantee you at the end of the session 4 marks will be in your pocket. So we are gathering all the 4 plus 4 plus 4 plus marks in the series of sessions, and in this session we are going to discuss about you want me to, hi Betu, Radhe Radhe, how are you? And before going for this standard geometries and exceptional geometries in VSEPR theory, we are going to discuss some tricks and hacks for this. Get ready my dear children. Before going for this VSEPR theory, I just want to bring you 2 surprising promos. One is score examination. What is this score? India's largest scholarship examination. Sri Chaitanya Academy is on a search of bright minds like you. So why it is India's largest scholarship examination? Now, nahi class, okay, you want me to take only in English? We can do it. Okay, anyways, we'll go with what is the score examination. This score examination is from any student can write this from grade 3 to grade 11 based on your standard. The question paper will be given. Betu, I am fine, thank you, and we'll see what is the special of this. And if you write this examination based on your performance, these are the incentives we want to give you. 2.5 crore rupees of the cash rewards. Can you believe it? It is true. And 350 crore worth of various levels of scholarships, and which includes gadgets like laptops and iPads and tablets kind of things. Yes, Suresh, and if you're ready to grab it, and I want to ask you, have you ever dreamed about going to NASA, United States of America, and visit it? Yes, we will take you. If you perform well, a group of students will be taken to a NASA trip, and it is a golden opportunity, my dear students. If you really dream well, and it is a golden opportunity, and you can do the best, and also up to 100% scholarships, and registrations are open now, and you can click in the description box, the link is given, and you can just go through the registration process. And this score examination will be conducted 2 times, September 28th and October 12th. So when you want to write the September 28th, the registration closes by September 26th, and October 12th registration closes by October 10th. Yes, Suraj. Now you can write this examination online or offline mode. If you want to write on online, you can simply sit at home and you can write. And you want to go for offline mode, you can visit any nearby Sri Chaitanya Academy. Depending upon the availability of the center, you can write the offline examination as well. And why not? These many gifts for you. Suraj, 2.5 crore cash rewards, 350 crore worth of scholarships, and up to 100% scholarship based on the course you opt for. This exciting gadgets like tablets and laptops, and most surprising NASA trip. Want to go to NASA? Stay tuned. And my dear students, this examination anybody can write. You can be a student of Sri Chaitanya, you need not be a student of Sri Chaitanya, you can be a student of any other private or government schools. Still, any student from grade 3 to grade 11. Various benches are there. We are conducting the score sessions also. There you can see the guidelines, and they are enriched with your scholarships, and it gives you a lot of impact on your potential exploring, and you will be benchmarked where you stand in the entire India. So India's largest scholarship examination, this is core. Don't miss, and registrations are open. You can click the link in the description box, you can fill it. Okay, mine is over. And one more thing I just want to give you, NEET test series. And this, especially this session, is meant for NEET examination preparation. Every faculty will come the respective way, and the physics teacher, chemistry teacher, botany and the zoology teachers are going to discuss the subjects. And you are also studying the subject very well. And I just want to say, if you are preparing for any examination, my dear children, it is important to know where exactly you stand. है ना? So, what is your improvement areas, what is your strength, and what is the way you have to improve your way. Hi, Deepali, hi, and please like the session, everybody. Suraj Kumar, I want you to like the session. Okay, anyways, if you ask a topper in the NEET examination that has been completed maybe in 2025, they also studied like you and they did hard work, but what makes the difference between an ordinary student and a topper? Hi, Deepanjali, right, okay. Now, what I meant to say, very good, Suraj Kumar. So, this is a live interactive session. I really encourage those students who are talking to me, and I love to talk to the students. So, Betu, if you ask any topper, they will say they undergone an assessment and they undergone a test prep. NEET test series is giving an ultimate key to your NEET success. It is a scientifically designed NEET assessment platform created by the top faculties from NEET examination, faculties from the Infinity Lane by Sri Chaitanya. Good morning, Anisha. Good morning, how are you? Now, when you do it, so you will be having a real-time examination scenario. Okay, Arhan, hello, Arhan. I want Arhan. Okay, yes. Suraj, still आप like मारना है, बेटो, right? So when you write this NEET test series, you can purchase it, and it is given for 11th standard का अलग पैकेज है, 12th standard का अलग पैकेज, repeater को भी अलग पैकेज है. Now we can see the based on the latest NTA examination pattern, you will be having a real-time simulation of this NEET examination. When you sit and practice for the NEET examination, you will be having a real-time experience how the NEET examination goes on. And most of the questions that you are going to see in the NEET examination may be correlated with this NEET test series. Violet, in the description box, the link is available, and you can click that link and you can purchase it. And और एक बात है, you can just apply the coupon code YouTube30 off, so that you are going to get flat 30% discount. है ना? That's good, Anisha. Right. Suraj Kumar. Perfect. So, how many of you like to do this? So, whenever you prepare for any examination, it is important for a proper assessment platform which tells you where exactly you stand, what is your improvement areas, and what is your strength. You need to know before going for the examination to enter into a dream medical college. है ना? So, anyways, I am going to start. Thank you very much for your cooperation. Let us start this VSEPR theory. So, my promotion is over. Let us go into the details about this context. Okay, bachcho, one thumbs up and fire emoji, everybody, so that we can start. So, postulates of VSEPR theory. What is this VSEPR theory? So, as you can see, valence shell electron pair repulsion theory. It says the geometry and the shape of a molecule. Betu? Right. So, when you talk about the geometry and the shape of a molecule, it is decided by the central atom in the covalent molecule. In the entire covalent molecule, you will be having an atom which is present at the center and its bonded atoms. So, the bonded atoms or terminal atoms, whatsoever you can say, and the middle atom is called as a central atom. The number of electrons present in the valence shell of the central atom decides what is actually its shape. I want to tell you the shape of a molecule gives an extensive importance of the total chemical properties of the molecule. Betu? Let's say, what are the postulates? Here, he wanted to say the shape of a molecule depends on the number of valence electrons present in the central atom of a covalent molecule. Bacho, this central atom, so this central atom contains electrons, right? number of sigma and pi bond together is said to be a bonded electron, Arhan, and these electrons are always exist in pairs, jodi jodi hai. And these pairs are two types. One is a lone pair of electron, another one is a bond pair of electron. Enemy warrior, that's good. So I like the charting, and you please continue, and let us see how the things are going to happen, right? So pairs of electrons are two types. One is a sigma bond atom, bond pair of electrons, another one is a lone pair of electron. ये क्या? A bond pair of electron, a lone pair of electron, दोनों का क्या फर्क पड़ता है? So these pairs of electron tend to occupy such positions, and the bond pair of electron is the pair of electron which is actually participated in the bonding. So that this bond pair of electrons exist between two nuclei of the bonded atoms, so that they are tightly bonded. When they are tightly bonded, they are compactly existed, so they don't move here and there, so that they cause less repulsion. While the lone pair of electron, that is organized and controlled by only central atom, so that there is no other atom on the other side, so that is going to have a more space and more repulsion. मैं क्या बोलना चाहता हूँ? Bond pair of electrons are the pair of electrons which are participated in the bonding, which occupy less space and which has less repulsion. Suraj Kumar, right? While this lone pair of electron is going to be controlled only by the central atom and has more space they occupy, and they are going to have the more repulsion. Betu, what are the 5 postulates of VSEPR theory? So these are the postulates, and I want to show you this. Okay, and these pairs of electrons tend to occupy such position, then these positions are important, and to minimize the repulsions among them and maximize the distance among them, right? So that they are going to give a specific geometry of the electronic arrangement. And so the valence shell is taken into the sphere of the electron pairs localized on the central atom. So it has a maximum distance from one atom to another atom. So when they make a repulsion, right? So they are going to have the multiple bonds, or a sigma bond and a pi bond. And if you say a single bond, it is called to be one sigma bond. There are two bonds, so one bond is said to be a sigma bond. If we want to say two bonds, उसमें एक sigma होगा और एक pi होगा. And you say a triple bond, उसमें एक sigma और दो pi bond होगा. So let it be carbon or oxygen, whatsoever it may be. So my dear students, double bond. A VSEPR theory का हिसाब से ये multiple bond is also considered to be one bond pair of electron. चाहे single bond होगा, double bond होगा और triple bond होगा. There a student is going to have kind of misconceptions. Leave it, you take a multiple bond is considered to be one bond pair of electrons. Arhan, 2 pi 1 sigma, that's good. So it could be in alkene if you say it is a carbon to carbon, alkane and alkene, and it is going to be alkyne. ठीक है बेटा? Now, so where two or more resonating structures can be represented, VSEPR model is applicable to any one of the acceptable structure. Any one of the acceptable structure. Okay. So among the electrons, the repulsion order is going to be lone pair repulsion on lone pair is going to be more as compared to lone pair repulsion and bond pair repulsion, and कम से कम bond pair repulsion के कम होगा. Understand? So this is the key point to understand. So based on this particular line, my dear children, based on this particular line, it was asked in NEET examination. PYQ is given, mind it. Don't worry, we'll do some questions based on the PYQ also, stay tuned. So Arhan, yes, because lone pair requires more space, perfectly what you said is correct. Suraj Kumar, following or not? Okay, आगे बढ़ना. So when these postulates, Betu, you asked about what are the 5 postulates. Let me just brief it. The shape of the molecule is based on the electrons on the central atom in the valence shell of the central atom of a covalent molecule. The electrons always exist in pairs. So these pairs of two types. a lone pair and a bond pair. So the bond pair cause less repulsion and the lone pair cause more repulsion. The order of repulsions are going to be lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. So these electrons around the central atom in a covalent molecules are arranged among themselves in such a way that repulsions among them are minimized, so that it is going to give a specific geometry or the shape of the molecule. समझ में आ रहा है क्या? बेतो clear? So this is the fundamental aspects. My dear students, you will be giving a question based on this theory and postulates. Yes, still you can get it the question like this. You can refer the NEET PYQ based on this, right? Yes. Arhan, so आगे बढ़ना थोड़ा सा, and I just want to say geometry versus shape. Who is going to give the geometry? Who is going to give the shape? So the geometry is given by the steric number, Sn, steric number, total number of lone pair as well as bond pair, while the shape is governed by only the bond pair. So only the bond pair is going to give this shape. So shape alag hoga betu and geometry alag hoga. Say an example, water molecule you take. So oxygen, it has 2 lone pairs and 2 bond pairs with hydrogen. So lone pairs are 2 and bond pairs are 2. Total is going to be 4. Steric number is going to be 4. जब steric number 4 होगा तो tetrahedral geometry होगा. And the shape is going to be given only lone pairs, so it is going to be a bent or V shape. Based on that you have to say. So my dear students, geometry is different, electronic arrangement of the central atom around this molecule, this is the geometry, while only and only bond pairs are taken into the consideration, that is going to give a bond and it is going to give a exact shape of the molecule. Arhan and Suraj, if you have any doubts, Beto, enemy warriors, all students, let us see here. So if you take sp hybridization आपको कैसा लगता है? This is the nucleus and it is going to be sp hybridized orbitals. It is going to be a linear. So it is 1 and it is 1. So steric number 2 होगा. When it is a steric number 2, it is going to be a linear geometry. It is going to be a linear geometry. Are you getting or not? So understanding, Suraj, understanding the things makes you very well. So learn the shapes and the geometry based on the hybridization. You know how to find the hybridization? Students, you know how to find the hybridization? I want to ask you a question. You want me to give a simple trick to understand the hybridization? Beto, Suraj, Arhan, so no worries, I am going to give you to find the hybridization. A simple trick is there. I want to give you the formula. Everybody take a pencil or a pen on a paper, write this formula. Look at this. H is equal to half into V plus M plus R minus C. Okay, that is good. What is V? So request a call back from the expert counseling sessions. You just click the link in the pinned messages, and you can also click the links that are available in the session description, so that you can get the various options that you can enroll in various courses and you can do the best. Okay, moving ahead, what is a H over here, V over here, C over here? Look at this. V stands for number of valence electrons. Number of valence electrons किस हिसाब से? इलेक्ट्रॉनिक कॉन्फ़िगरेशन का हिसाब से. एंड इसमें मोनोवैलेंट एटम, सेंट्रल एटम को कितना सेंट्रल एटम, मोनोवैलेंट एटम्स लगा हुआ सेंट्रल एटम को, सो दैट इज नंबर ऑफ मोनोवैलेंट एटम्स. मोनोवैलेंट एटम्स. जब आपको ऑक्सीजन आए ना, तो whenever oxygen comes na, it is a divalent na, you take it 0 value. That's a key point. And whenever C comes now, it is going to be charge. What is this charge? This charge, please reverse the sign. बच्चों, whenever charge is 0, make it 0, plus or minus 0. Whenever you have a charge, positive charge, make it negative value. Okay, whenever it is a negative charge, make it as a positive value. Now, this is the key point. When you have to solve the H value, that is number of hybrid orbitals. So, number of hybrid orbitals. So, whenever number of hybrid orbitals चाहिए तो H is equal to 2 हो सकता है, H is equal to 3 हो सकता है, H is equal to 4, H is equal to 5, okay, H is equal to 5 or 6, whatever it may be. Okay, so H is equal to 5 and H is equal to 6. So, उसमें मैं क्या बोलना चाहता हूँ? H is equal to 2. It indicates this is your sp hybridized. जब sp hybridized आता है ना, it is a linear. Simple, it is a linear. How we are connected the hybridization to give the shape and the geometry of the molecule. So, in today's class, we are discussing about VSEPR theory hacks to find the shape of the molecule. So, this is a hack to find the regular geometries. And if it is a 3, it is going to be sp2 hybridization. This is going to be trigonal planar. You know how trigonal planar appears? Trigonal planar. Okay, Betu, I want to ask you, if H is equal to 4, what could be the shape of the molecule? Students, what could be the shape of the molecule? Suraj, Arhan, Betu, what is the hybridization? It is going to be sp3 hybridization. What is the geometry? It is going to have tetrahedral. It is going to be tetrahedral. Hey, that's perfect. And if it is H is equal to 5, it is going to be sp3 dehybridization. If it is sp3 dehybridization, what is the shape of the molecule? It is going to be trigonal bipyramidal. Trigonal bipyramidal. आपको पता ही होगा. It is going to be TGBP. आपका जैसे phosphorus pentachloride में. Suraj, right? Now, and it is sp6 means it is going to be sp3d2. So, it is going to be octahedral. It is going to be octahedral. So, the total VSEPR theory, these are the regular geometries you are going to have. Exactly, Betu, what you said is correct. So, my dear children, VSEPR theory, if you study it, definitely it is going to have a backbone in the chemical bonding. Not only in the chemical bonding, total inorganic chemistry is based on this VSEPR theory. Okay, so you can do P block elements, you can do S block elements, you can do D and F block elements. Mostly P block elements is connected over here. Sometimes you can go ahead with your organic mechanisms also. When you say SP, SN2 reactions in the organic chemistry, it is all depends upon its shape and or hybridization of the orbital, if you remember. Okay, anyways, we are going to conduct a few more sessions based on the organic chemistry. Maybe in the this month and I will start with organic chemistry, so that you are going to really enjoy those sessions. Dear students, if you have any doubt in this particular slide, you can ask us. My dear children, this is a live interactive session. So, in this live interactive session, we can have a two-way transitions between you and me. You can ask any doubt related to the current context. I am going to definitely honor whatever the questions you ask. Right? Fine. Arhan, you kept quiet. Why so? You kept quiet. I am expecting a question from you. Okay. Now, if you don't ask a question now, I will going to ask. Suraj Kumar, next. It is about sp hybridization. आगे बढ़ना sp2 hybridization का. It is going to be sp ताकि इसको linear होगा sp2 in the trigonal planar. It is going to be, this is your trigonal planar, you can see. Now, it is an sp hybridization, steric number is 2. So, it is going to have a linear geometry. So, the geometry appears like this. Fine, like it? That's good. Now, let us go into the sp2 then. Now, the steric number. Talking about the steric number. So, it is going to be sp hybridization, steric number is going to be 2 bond pairs and 0 lone pair. it is going to be having 2 pi bonds. If that is the case, C double bond O, C double bond O. So I can see a lone bond pair of electrons here. So the bond pair of electrons, similarly it shows a linear. Sir, double bond is there, I can take 2 bond pairs. No, I said VSEPR theory always consider a bond pair is said to be a single bond or a double bond or a triple bond. A multiple bond is said to be one bond pair. One bond pair, another bond pair. It is a linear. So that's fine. And talking about one bond pair. So steric number 2 बोल रहे थे. Steric number 2 means it could be a combination of 2 bond pairs. It could be a combination of 2 bond pairs and 0 lone pair. So this is an example. It could be one bond pair, one lone pair having 2 pi bonds. You are going to see nitrogen. It is also a linear molecule. You just see. So steric number has to be taken into the consideration of various combinations. That is the best way to learn the VSEPR theory and geometries of the molecule. So if you open a textbook, you will be given the total table. A table you have to by heart it or not? Not required, not necessary. I am against for the by hearting things and all. Suraj Kumar, right, I want you to still waiting for your like button here. If you click the like button, I can see that. Okay, so let us say if it is sp2 hybridization. sp2 hybridization ka geometry is going to be trigonal planar. So it is going to be trigonal planar. So triangle will come na. So it is going to be trigonal planar. So steric number 1, 2, 3. It appears like this. So in this sp3, it is going to be a sp2 hybridization, sp2 hybridization, sp2 hybridization. So triangular in shape, and the angle here you are going to get perfectly 120 degrees, right? 120 degrees. And you can have A, B, 3 type. A is the central atom, B is the bonded atom, 3 bonded atoms are there. So in this steric number 3, let us take 3 combinations. Okay, let us take come second 2 combinations. Okay, let's see here. 3 bond pairs and 0 lone pair. So having no pi bonds. Having no pi bonds. I can introduce pi bonds as well. Look at this. If that is the case, BF3, boron, fluorine, fluorine and fluorine. उसमें आपको bond angle कितना देख रहा है बेटा? 120 degrees. मैं बोल रहे हैं ना? And here you can see the beautiful presentation. You are going to get a triangular and the molecule appears to be flat in this way. If you see this molecule in this way and it is seen, it is a flat. The molecule is going to be flatter. You feel this structure. Let it be any molecule will be given in this examination. Right now in the class I am discussing BF3. It could be any molecule. If you have that confidence, you can write it better. Agree? Agree? Yes. Rakib. Rakib, I want to say, I want to know what you want to ask. Okay, now 3 bond pairs and 0 lone pair और एक combination निकालना है. 2 bond pairs, 1 lone pair. ताकि 2 + 1 steric number 3 होगा ना. Now it is going to be 3 bond pair, 0 lone pair, उसमें एक pi bond होगा. I would be very happy if somebody give an example for this. Very happy if you give somebody example for this. It could be ozone, it could be sulfur dioxide, right? So that much command you need to have about the examples. You can say carbonate bhi hai, ozone, okay. And here this carbonate you can see it is a bond pair and a bond pair with 1 pi bond, and it is having no lone pair of electron on the central atom. You can claim this is, sir lone pair दिखाई दे रहा है ना, lone pair 0 बोल रहे क्यों? Yes, lone pair is there, not on the central atom. Central atom भरा हुआ. Fine beta. Okay, now this is your carbonate structure. Again I can see this is your triangular planar. Steric number is going to be 3. So like that you interact with the structure and you practice it, and definitely you will be getting one question from the basics, right? Beto, now let us see the combination 3 + 0. 2 plus 1 lena. Now 3 plus 3 bond pair, 0 lone pair, but I just want to have 2 pi bonds. Arre, ye kya? Is somebody give me an example for this? Somebody give an example for this. Somebody give an example for this. Suraj, it could be sulfur trioxide bhi ho sakta hai na. Now we can say CpO2Cl. It is going to be sulfur trioxide bhi can be. You are going to see sulfur double bond O, and it is going to be double bond O. It is going to be TGB, trigonal planar. Maybe this structure, this molecule is not that familiar to you, but it is true. PClO2, fine, PClO2 is another example where you can see a triangular planar structure, steric number 3. And you have 3 bond pairs and 0 lone pairs having 3 pi bonds. You can see SO3, CO3. It goes like this, 2 bond pairs and 1 lone pair having 1 pi bond. So various molecules that are being shown here. So how do you get 2 bond pairs, 1 lone pairs? There you can see a ozone molecule. There you can see sulfur dioxide bhi ho sakta hai. Sulfur dioxide, sulfur double bond O, and it is going to be O, and it is a bent shape. You can see a bent. You can see a bent. Geometry is going to be, you can see 1, 2, 3. It is a geometry is related to the steric number, trigonal planar, but the shape of the molecule is bent. These are the various acts that you need to know. Betu, any doubt? Now let us see various combinations now. 2 bond pairs and 1 lone pair. Thoda aage बढ़ना है, and 2 bond pairs, 1 lone pair having this time 2 pi bonds. So 2 pi bonds, sulfur dioxide, you can say double bond O and double bond O. You can say it is as a day2 bond or a sigma and pi bond. It is going to be again, it is a bend in shape. And steric number 3, and it is going to be a trigonal planar structure, geometry, and the shape is going to be a bent, sulfur dioxide. And one more, if it is a sp3, steric number 4, so that 4 are going to be tetrahedrali arranged. This is your tetrahedral arrangement. You can say 4 like a cross. No, this structure is not like a cross. You can see the tetrahedral structure appear like this. One bond is pointing towards you, one bond is going behind you, 1, 2 are on the plane of the people. Now you can say A is a bonding central atom, A and B4, it is going to be tetrahedral. You know this is a tetrahedral. How to say it is a tetrahedral? You can say this is a face. Now you can say it is a face. And how many faces are there? It is another face. It is another face. Total 4 faces can be seen. So it is said to be a tetrahedral geometry. And let us see the combinations of sp3 hybridization. I already given you how to find the hybridization. The formula, if you remember the formula, it is given now. H is equal to half V plus M plus R minus C. H is equal to number of hybrid orbitals, and V is the number of valence electrons in the central atom, and M stands for number of monovalent atoms attached to the central atom, and C stands for the charge. So if the charge is 0, neutral, so its value is 0, and if it is a positive value, take a negative charge. If it is a negative charge, take a positive value. Okay, Rakib. So Suraj Kumar, let us go ahead, various combinations of this. Coordinate 4, steric number 4 ka composition, you can see variations, 4 bond pairs and a 0 lone pair. You can say it is a methane. How do I know methane is tetrahedral? You can say electronic configuration का हिसाब से carbon is tetravalent, ना? Electronic configuration का हिसाब से carbon is tetravalent. So it is having 4 outer shell electrons, है ना? And hydrogen is going to bind with carbon. So hydrogen is going to give 1 electron, hydrogen is going to give 1 electron. So hydrogen is going to give 1 electron, hydrogen is going to give 1 electron, right? So that I can say this is a bond and this is a bond and this is a bond and this is a bond. So number of bond pairs of electrons are 4. So steric number 4 bond pairs are there. So ये रूल का हिसाब से ये वाला tetrahedral होगा, methane, it is tetrahedral. So what is the angle here? Suresh and Betu, what is the angle here? 109.5 degrees or otherwise 109 degrees 28 minutes. Both are same. Fine. So this is the simplest animations that I can show you and can give you the best. So when you have this best of this, you never forget it. I can take simply on the blank page, I can explain you clumsy dikta, but you can see the best pictures that I am showing you thanks to the content department. They are doing a very good job to learning process, better learning experience के लिए. Thank you very much and let us see 4 bond pairs, 0 lone pair, लेकिन उसमें एक pi bond introduce करना चाहता हूँ. When you do so here, you are going to get POCl3, POCl3. So phosphorus Cl, Cl, Cl oxygen के साथ है, sigma एक pi bond है. You have a pi bond, but it is going to be tetrahedral in shape, POCl3, right? So Betu, any doubt? That is going to be very good examples. Everybody, please take a screenshot of this. Very good examples, no? Take a screenshot of this. Okay, that's good, Betu. So bachcho, moving ahead, I want to take you the various combination. So simply I can drop a table and I can explain it. But if you want to learn it, it's a process. You take the steric number and take the various combinations of bond pairs and lone pairs. Okay? Where you can see 4 bond pairs, 0 lone pair, but 2 pi bonds. Can you guess any molecule? Can you guess any molecule? Here we can say SO2Cl2. What is the name of the molecule? SO2Cl2. SO2Cl2. Sulfuryl chloride. In chemistry there is a cheating. Organic chemistry में आना है और एक चीज है SOCl2, वो चीज अलग है, वो चीज अलग है. SO2Cl2 is called a sulfuryl chloride and SOCl2 is called thionyl chloride. कहाँ देखा है बोला? ये ज़्यादा दिखता. Both are good chlorinating agents. Thionyl chloride is used. Thionyl chloride is used in making the Darjan's reaction. The best way to prepare alkyl chloride from alcohols is an eye reaction. Okay, in the presence of pyridine, in the absence of pyridine. Okay, that's a different matter in the organic chemistry, but both are good chlorinating agents. Why this obscure name? Chemistry is given like that. Okay, so this is a thionyl chloride. So this is, we are not talking about SOCl2, we are talking about sulfuryl chloride SO2Cl2. Yes, double bond O, and it is a Cl and a Cl, tetrahedral in shape. Rakib, this is tetrahedral in shape. Rakib, I am expecting you to please like the session. Okay, so moving ahead, 4 bond pair, 0 lone pair फिर भी, and having 3 pi bonds. Having 3 pi bonds. Can you guess a molecule? So we are going to learn the examples in such a way that weird examples we are getting, but all are there in the chemistry textbook, in the NCERT, and there is no need to say it is out of syllabus, inside the syllabus. If it is given in the NEET examination as it is there in the NCERT, it will be given in the NEET examination, no doubt about that. You can see Cl FO3. It is tetrahedral, you can say 3 bond pairs. 4 bond pairs and 3 pi bonds, you can say 3 pi bonds. It is tetrahedral in shape. Okay. And my dear children, here one more important thing. 4 bond pairs, 0 lone pairs having 4 pi bonds. Are you getting it? So introduction of a pi bond doesn't change the geometry as long as there is no lone pair. आप शांत रखना, ये tetrahedral ही होता है. You can say this is going to be xenon tetroxide, 𝑥eO4. It is an explosive compound. It is tetrahedral. Okay, it is an explosive compound. We are connected to group 18 p block element, grade 12. So I am integrating the entire textbook in this session. You just go through this, and also I want to take one lone pair in the steric number 4. उसमें 3 bond pairs होगा, एक lone pair होगा. बच्चों, in this you can say you are going to see NH3, your favorite molecule, ammonia, nitrogen. Arey, how do I know there is a lone pair? Now you can see the electronic arrangement is going to be trigonal planar. No tetrahedral. You can say nitrogen जो है ना, this is your nitrogen. Electronic configuration का हिसाब से it is going to be 1s2, 2s2, 2p3. So outer shell में आपको कितने इलेक्ट्रॉन दिख रहे हैं ना? 5 electrons बेटा. These 5 electrons are going to be 1 and 2, 3, 4, 5. And one hydrogen is going to be forming a bond over here. One hydrogen is going to form a bond over here. One hydrogen is going to be form. So it is going to be bond pair, and a bond pair. आपका आ रहा है ना, this is going to be lone pair. आपका bond pairs कितना है बोलो? Bond pairs are going to be 3 and the lone pairs are going to be 1. Steric number is going to be 4. So it is going to be tetrahedral arrangement. So you have 3 bond pairs and lone pairs are 1. Steric number 4, and it is going to be geometry. Tetrahedral shape is going to pyramidal. Veto, any doubt? It is going to be pyramidal. Moving ahead. Now the combination 3 bond pairs, 1 lone pair, but उसमें एक pi bond introduce करना चाहता हूँ. If you introduce one pi bond ना, it is going to be SO2 Cl2, SOCl2 or SOF2. You are going to get a single bond and a single bond, sigma bond and a sigma bond and a pi bond. It is going to be again pyramidal in shape. Any doubt, bachcho? Writing the structures, Beto? Writing the structures. My dear children, this is a live YouTube session where you are going to have the live two-way interactive session. It is not a radio session. So you can take a pen and paper and simply attend my class. It's a free of cost. To have this kind of lessons, you need to go to a coaching center and you have to pay huge money, travel to a long way, but you need not have to pay anything to us. Simply sit in the class, attend the class for free of cost. My dear children, we don't want to expect anything from you. Please like the session. That is more than enough for us. And subscribe to Infinity Learn NEET YouTube channel to stay tuned for very good number of sessions like this, right? Moving ahead, 3 bond pairs, 1 lone pair having 2 pi bonds. 2 pi bonds. So उसमें ClF2O. Okay, so ClFO2. You are going to see a pi bond, you are going to see a pi bond and a sigma bond. Still it is a pyramidal in shape. Still it is a pyramidal in shape. And I want to say 3 bond pairs, 1 lone pair having 3 pi bonds. In that way, 𝑥eO3, group 18 p block elements, grade 12. It is an explosive compound. It is given in the NCERT textbook. It is given in the NCERT textbook. So we are talking about NCERT line by line उठा के आपको sessions बना हुआ. So when you attend the class, you never miss anything. and definitely you will be doing great in your NEET examination. Stay tuned for such type of sessions, my dear students. Here I want to check the combinations. Steric number 4, उसमें 2 lone pair हो सकते हैं, 2 bond pair भी हो सकते हैं, and you can have no pi bond in that. You can say that H2S, rotten egg smell. In that way, you can say sulfur and hydrogen and oxygen, you have 2 lone pairs of electron, 2 bond pairs of electron. The shape of the molecule is going to be bent. H2S molecule is like a bent. It is, you can have water also taken into the examination. H2O is also another example. Yeah? Oxygen, hydrogen and hydrogen. And please mention in the comment box or a chat box what is the angle here and what is the angle here. What is the angle here and what is the angle here? I want to know in the comment box. Okay? You want me to tell you or you will tell? Betu, will you tell? Please mention in the comment box or a chat box. Okay? Anyways, this time 2 bond pairs and 2 lone pairs, but I just want to introduce you 1 pi bond. Right? So when you introduce 1 pi bond, it is going to be ClO2, very good oxidizing agent. ClO2, and it is going to be a bent shape. It is an oxygen beta, it is an oxygen. It is a bent shape. This ClO2 is going to be a good bleaching agent. It is used in the paper and textile industry. Mostly in the paper industry, it is a good bleaching agent, oxidizing agent. Good oxidizing agent, OA stands for oxidizing agent. It also acts as a bleaching agent. You will be forming a question based on that also, right? And also 1 bond pair and 3 lone pairs having 0 pi bonds, it is simply ClO minus. It is going to be ClO minus, and it is a linear. What is the shape of the molecule? You tell me. It is a linear. Is my voice is audible to you? Hope there is no noise around us. Okay. Now, let us talk about sp3 geometry. Steric number is 5. It is going to be trigonal bipyramidal. On the triangle, ऊपर एक pyramid होगा, नीचे और एक pyramid हो सकता है. This is what is called as a trigonal bipyramidal. So I just want to say TGBP. So TGBP, trigonal bipyramidal. You can see this is your triangle beta. You can see this is your triangle. On the triangle, you can see a pyramid can be seen above the triangle. You understand? And below this pyramidal और एक below this triangle और एक pyramid दिखाई देना. And you know what is the angle? What is the angle over here? I can say the angle between these two is going to be 90. What is the angle between these two is going to be 120. There are 2 types of angles, 90 and 120. If it is a regular geometry, you have to know the angles as well. The best example is going to be PCl5. I would like to say it is going to be 120 here between these triangles, and you're going to have the 90 over here, right? And sp3d2, and you can have 5 bond pairs and 0 lone pairs. This is going to be PCl5 trigonal bipyramidal. It is said that TGBP, trigonal bipyramidal. You know, these bonds are going to be axial, equatorial bonds, and these bonds are going to be axial bonds. You know, axial bonds is going to be short, and the equatorial bonds are going to be long. Equatorial bonds are going to be long. So this is given in the NCERT, and it is going to give a very good information. That is the reason why whenever PCl5 is heated, it is going to dissociate to gives rise PCl3 and Cl2. Axial bonds टूटना है. Understand? So the behavior of the molecule can be assessed based on these bonds also. That is the important aspect as far as the shapes and the geometries are concerned. Okay, Betu? So those students who are online, if you have any doubts, you please let me know. Otherwise, one thumbs up and fire emoji to move ahead. Rakib, Betu, Suraj Kumar, okay, Anjani, okay, come on. If you have any doubts, please let me know. Moving ahead, various combinations. 5 bond pair, 0 lone pair. That 1 pi bond introduce karna hai. And if you introduce 1 pi bond, you can say SO to F4. It is going to be a trigonal bipyramidal. So sulfur has no lone pair of electron, but you are going to have 1 pi bond. You are going to have 1 pi bond. Okay? This is a very important molecule. It is trapped like you SF4 𝒑𝒐𝒂𝒊𝒕 structure, and this molecule and that molecule look alike, but it is perfectly trigonal bipyramidal. Okay, so Beto, are you there in the class? Come on, 5 bond pairs and 0 lone pairs. So in that, I just want to introduce 2 pi bonds. When you introduce 2 pi bonds now, BrO2F3. So halogens has an extensive properties to introduce, expand its covalency, and also it is going to form a very good number of multiple bonds. It starts from the third period and fourth period. So these many pi bonds and extensive covalencies are not done for these second period elements. So we are connected to the periodic table and the p block elements. So we are in the middle of the p block elements. Halogens group 17 elements in this NCERT part 2 textbook in the grade 12, part 1 textbook in grade 12. It's important. And also you can see 5 bond pairs and 0 lone pair having 3 pi bonds. Array, want to introduce one more structure here. You can see 𝑥𝒑𝒂𝒊𝒕 Okay, there is a pi bond. There is a pi bond over here. 𝑥𝒑𝒂𝒊𝒕 Okay, and it is going to be again trigonal bipyramidal. Fine. Now you can see 4 bond pairs, 1 lone pair. 4 bond pairs, 1 lone pair. My dear students, it is a trigonal bipyramidal structure. Okay. So I can have this TGBP, lone pair is placed in this axial position. It is your axial position, and lone pair is present in the equatorial position. So मैं क्या बोलना चाहता हूँ? It is a 𝒑𝒐𝒂 structure. It is actual structure. It exists like this. A simple trick: whenever a lone pair is present, whenever electronegative element is there, whenever a multiple bond is there, what are the 3 conditions, beta? Whenever lone pair is there, whenever electronegative element is there, whenever a multiple bond is present, in the TGBP, it has to be placed in the equatorial places, so that it is going to have a 𝒑𝒐𝒂 structure. In this 𝒑𝒐𝒂 structure, axial bonds are not equal to equatorial bonds. It's very important. उसमें equatorial कौन सा होगा? ये equatorial होगा, ये axial होगा. You understand? It's learning very good things. So I just want to show sulfur, and it is going to be F, F, and it is going to be 𝒑𝒐𝒂 structure. You played the park in the 𝒑𝒐𝒂, right? That's perfect. That's perfect, my dear students, right? Okay, moving ahead, I just want to introduce you one more thing here. 4 bond pairs, 1 lone pair. Okay, you can take SF4 as well. Yes, it is expected, and it is also expected the same thing. Now you just want to say here, do you find this exactly 180 degrees will be there? Absolutely no, because of this lone pair repulsion, the bond angle is going to be less than that expected. That is important. Actual structure, neat tricky things will be there. In the presence of lone pair, It is the rarest occasion you never get 180 angle, mind it. Even in CLF3 also, T shape will not. So it is not perfect T shape. Are you getting or not? Clear? That's very important, my dear children. Are you going to see the shape and geometry of some simple molecules, ions with central atom having the one or more lone pairs of the electrons? You can say, if it is AB2 type, AB2, it is going to be A, B and B. It's a linear. Example, beryllium chloride हो सकता है, mercury chloride भी हो सकता है. And AB3, it is going to be trigonal planar, BCl3 and BF3. Right? And you can say tetrahedral, your favorite molecule methane and ammonia ion, ammonium ion are going to be. So hybridization could be anything over here, right? So in general sp, sp2, sp3 hoga. Beto, any doubt? So this is how the tables are being given. Aage badhna thoda. So if the number of electron pairs, steric number 5, it is going to be TGBP, trigonal bipyramidal rakib, and it is going to be giving you PF5 and PCl5, PF5 or PCl5. Okay? And also steric number 6, it is going to be a octahedral SF6 sp3d2 hybridization hoga. Any doubt? If you have any doubt, please let me know. And थोड़ा सा लोन पेयर इंट्रोड्यूस करके आपको दिखाना चाहता हूँ. So if E is the lone pair of electrons, so I just want to say AB to E, steric number 3, and the geometry is going to be trigonal planar, but it is going to be bent in shape. SO2 and O3 comes under this category. And AB3E, it is going to be steric number 4 geometry, electron geometry is going to be tetrahedral, and this is a geometry, this is going to be geometry, and it is going to be the shape trigonal bipyramidal, trigonal pyramidal ammonia, it is going to be like this. Fine. Now moving ahead, Rakib, and AB2E2, it is going to be bent, H2O is your molecule, and AB4E, it is going to be seesaw structure, SF4 is going to be a molecule, just we discussed this. And you can see AB3E2, so steric number 5 trigonal bipyramidal is the geometry where T shape ClF3. You can see Cl, and it is going to be F, and it is F, and 2 lone pairs are there. So the theta is going to be less than 90, mind it. That is very, very important. That is very, very important. Fine. And you can see AB5E, 5 and 1, it is going to be octahedral electronic geometry, and you are going to see a square pyramidal. You can see a square pyramidal. Okay, this is your square pyramidal lone pairs with. And BRF5 is the example for this. BRF5 is the example for this. Okay, and moving ahead, AB4E2, you are going to get 4 plus 2 is going to be 6. Electron geometry is going to be octahedral, and the shape is going to be simply square planar, and the example is going to be XEF4. XEF4. And by looking at the structure, you can say how to do that as well. And VSEPR theory gives you a lot of impact in deciding the properties of the matter as well, molecules as well. Now you are going to see AB to E, it is going to be sulfur dioxide, it is a bent. Theoretically the shape should have been triangular planar, but actually it is found to be bent or V shape because the lone pair of electron is seen here. So they are going to make a repulsion, because of that repulsion the bond it is going to be shown in the bent way. Okay. Similarly, ammonia AB3E it is going to be. So this description is important, and this description you just have a screenshot of this, and the assertion and reasoning type question from the NEET examination definitely you can expect from here, right? Any doubt, bachcho? Take a screenshot everybody. Take a screenshot everybody. 3, 2, 1. Exactly, exactly. Now moving ahead. So AB to E2, you are going to have water molecule. The shape of the water molecule is bent. It has 4 intermolecular hydrogen bonding tetrahedrali arranged. That's the reason why it is going to give open case structure in the solid state. So because of this open case structure and the shape, the density of water is going to be, density of ice is going to be less than water. That's the reason why ice float on the water. Okay. So like this you can say SF4, and I can get, this is one type of structure I can get, this is one type of structure I can get, which is more reliable structure, and this is more stable because here lone pair repulsions will be, lone pair bond pair repulsions is going to be minimum. So I want to say the structures and different formats will be given in the NEET examination, bachcho, and you have to identify which is a reliable structure. Mind it? Fine. Betu, hope you like this session today. So those students, please like this session. We are done from this VSEPR theory. In this VSEPR theory, we discussed about what is the actual postulates of VSEPR theory and how to predict the molecular geometry and the shape and the hybridization, everything. In the next sessions, I just want to talk about molecular orbital theory. I want to give good things about the thermodynamics in the coming week as well. Okay, thank you. I am done from my side. Please like this session, share with your friends, and subscribe to Infinity Land NEET YouTube channel. Thank you. Thank you very much. God bless you. Signing off, Suresh, Faculty of Chemistry from Infinity Land NEET YouTube studio. Bye-bye.